Okay, so let's continue example 2. And there's actually a little typo. I had the correct row of x, and then I just wrote 1/2. So just to, let's get pink. So this guy, right, that should be 3/2 because our row of x was 3/2. But I wrote 1/2 y, I don't know why. So again, this should be, if I multiply both sides by the row of x, which should be, again, 3/2, okay, dy dx, so that one's fine. And then if I multiply this guy, so this is still, right, this should be 3/2. And we can simplify this, right, this is just some algebra, right? 3/2 minus 1 or minus 2/2 is 1/2. So we're left with x squared plus 1 to the 1/2. That's why they have 1/2 in the book. And then here, similarly, right, this should be 3/2. Same thing, minus 1 is x squared plus 1 to the 1/2. And then, of course, times 6x. So again, I was just using when you have, you know, a to the m divided by a to the n, right, same base, you just subtract the exponent. So it's just a law of exponents rule in like Algebra 1. Okay, so now we can see that this guy is a derivative with respect to dx of our x squared plus 1 to the 3/2, right? That's always going to be the row of x, our correct row of x. And let me just get white here, times, and it's always going to be times y, right? Our solution that we want to find is equal to, and I'm just going to bring this 6 over just to the front. Okay, so now we're ready to integrate. So we can integrate both sides. And let me move this, whoops, move this up a little bit. Right, and here we have the inverse functions, right, so that's gone. And we are left with x squared plus 1 to the 3/2 y equals, and if we integrate this guy, we can take out a nice 6 for now, and of course that's with respect to dx. So 6x x squared plus 1 to the half dx, and it looks like here we can probably use a u substitution. Okay, so let's use the u substitution, and let's see, so we are, well, first I'm going to go ahead and write, you'll see why in a minute why I'm doing this. Well, actually, let me just erase this part. So we want to focus on integrating this guy. So I'm going to let u be x squared plus 1. So du is 2x dx. And I'm going to solve for x dx, which is just half of du. Why? Because I have an x dx right there. So just scooch this up. Okay, I have, so again, focusing on that part, so 6 times the integral of, and then I'm going to go ahead and write, okay, x squared plus 1 to the 1/2, and then I'm going to write x dx just together so it's easier to see what I'm doing. So here I have 6 times the integral. Well, I let this guy be u, so that's u to the 1/2. And then I just found what x dx was in terms of u. So that's half of du. So now our integral looks a little bit nicer. Well, we can definitely take out that half, right? It's just a constant. So half of 6 is 3. And, ooh, this looks very nice because this is just an integral. I mean, we can integrate using the power rule. So we have 3 times u to the 1/2 plus 1, right, or 1/2, or 3/2. And I can divide by 3/2 plus c, but remember this 3/2 is really, times 2/3, right? When you divide a fraction, I multiply by the reciprocal. So 2/3 times 3, which is going to be great. Because then we're going to have u, which is x squared plus 1 to the 3/2 plus c. So our integral is, this guy right here. So now that we have integrated, let's put all of this together. And so again, I'm working from here. And we have, okay, so we have 2 times x squared plus 1 to the 3 halves, of course, plus our constant c, plus c, and actually that's the right hand side. I wrote it on the left hand side, but that's the right hand side, equals, and then we have our x squared plus 1 to the 3/2 times y. So again, sorry about, it's the same thing, but let's see, in yellow. So this guy, right, it's on the left. I just put it on the right. And then my integral, right, this guy that I integrated became this guy, which is now this guy. Okay, so again, our goal is to find the solution to this differential equation. So it's right here, right? That's our y of x. So we can multiply, again, just using some algebra. I want to multiply by x squared plus 1 to the negative 3/2, because that's going to give me a 1. And if I, of course, do it to the right-hand side, I must do it to the left-hand side, so I don't change the value. I have 2 times x squared plus 1 to the 3/2 times our this guy, right? I'm just distributing. X squared plus 1 to the negative 3/2 plus x squared plus 1 to the negative 3/2 times c, and then I know the right hand side is just going to be y of x. So I distributed this guy and this guy, right? I just did it to here and to this guy. So almost done, right? This is just a big 1. So 2 times 1 is 2 plus x squared plus 1 to the negative 3/2 c equals y of x. So that is our solution to the differential equation. There's no initial condition, so this is the general solution. There is no, we could find a particular solution, but they don't give us an initial condition. So general solution.